When we teach about multiplying binomials together, we're typically teaching about just multiplying one binomial by a second binomial. And when we do this, we do the FOIL method. And while there's nothing wrong with that in itself, it's somewhat limiting when we go to multiplying three binomials together at once or four binomials together at once. And so what I would like to show you today is an alternative method of doing this. I'm going to start off talking about something which might seem to be unrelated, but I want to get you thinking about something. We're going to talk about combinations, and combinations are ways of taking a set of things and making new subsets of it. So note this thing here, this set has four elements, and what I want to do is to show how we can make subsets of different size. So first off, if we want to make subsets of size 1, well, what do? Well, we can just say, well, the single element of A is a subset of size 1. The single element B is a subset of size 1. The set C is a subset of size 1, and D is a subset of size 1. Now, if I want to check size 2, all right, well, A and B, and A and C, and A and D, and so this will be all of the subsets which have A in them of size 2. And then I would say B and C, and B and D, and finally C and D. All right. Size 3, another way of looking at this is if it's size 3, how many subsets we get with just leaving out one of these? Well, it would be A, B, C, and leaving out D, A, B, D, and leaving out C, A, C, D, I left out B, and then B, C, D, I left out A. And subsets of size 4, well, that is just going to be the whole set itself. D. And the first one of these will have 4 elements. The second one has 1, 2, 3, 4, 5, 6. The third has 1, 2, 3, 4. And the last one has 1. And I left out the subset that has no elements, there's only one of those, and that's the empty set. You might know if I included that, you might recognize these numbers 1, 4, 6, 4, 1 as numbers from Pascal's triangle. And so 4 choose 0 is 1. We read that 4 choose 0. 4 choose 1 is 4. 4 choose 2 is 6. 4 choose 3 is equal to 4 again. And then 4 choose 4 is equal to 1. Okay, and so given these, okay, I wanted to, this is going to come up in what we do next. I want you to just kind of think about the process of making these. It would be instructive maybe for you to like go ahead and do this for a set with 3 elements or a set with 5 elements to just get the swing of sort of how you do this, okay? Because we're going to apply it in what we do next. Okay, so now we're going to start multiplying binomials, and we'll say let's x plus x1 times x plus x2. And if you are familiar with the FOIL method, you would say, okay, x squared plus x1 plus x2 times x plus x1 times x2. And so this is the product of the binomials. Let's go with the next one. Say x plus x1 times x plus x2 times x plus x3. Well, we multiply these together. The first, we do them in pairs. The first one we've already done. We would have x squared plus x1 plus x2 times x plus x1 times x2, and we want to multiply that times x plus x3. Well, taking the x from the bottom and multiplying it through each term from the top, this gives us x cubed plus x1 plus x2 times x squared plus x1 times x2 times x. And then when I multiply it through the second, the x3 through, I would say this is x3 times x squared plus, okay, x1 x3 plus x2 x3 times x, and then finally x1 x2 x3. It looks like the plan ahead sign. Okay. Anyway, we add these terms together. We get x3 plus x1 plus x2 plus x3 times x squared plus, okay, x1 x2 plus x1 x3, okay, plus x2 x3, and then the final term, right, is x1 x2 x3. And so I want you to, given the fact that we've just talked about combinations of things, I want you to kind of look at this and say, hey, this first one is sort of like the terms are all like 3 choose 1. The second one, they're all like 3 choose 2. And the third one, they're like 3 choose 3. And of course the leading coefficient is like 3 choose 0. And so, but instead of putting the numbers down there, we're adding together the actual sets. So we can actually set this down in a more general setting if we take, okay, x plus x1, x plus x2, etc., out to x plus xn, and multiply them together. The first term is going to be x to the nth power. The second term, I'll be just adding up all the singles, x1 plus x2, all the way through xn, times x to the n minus first. The third one, I'll be multiplying all the possible ways I can do things in pairs. So this will be x1, x2 plus x1, x3, and we would continue doing all the possible ways we could multiply them in pairs, ending with xn minus 1, xn times x to the n minus 2. The next time we go all the possible ways we can multiply them in triples. This will be x1, x2, x3 plus x1, x2, x4, and so on until we get to xn minus 2, xn minus 1, xn times x to the n minus 3, and continue in this way. The next to the last step, we would go x1 times x2 all the way through xn minus 1 plus getting multiplying all the different ways that we can get n minus 1 of these constants together until we get x2 times xn times x, and then finally x1 times x2 times x3 times x to the nth, like so. Okay. And so it's a nice, pretty formula. You can, if you happen to know what the binomial coefficients are, you can check how many terms you should expect along each of these. Okay, so but a nice example would probably work well at this point. Okay, so as a nice example, I've chosen a nice special case here where I'm doing x minus 1 times x minus 2 times x minus 3 times x minus 4. I had worked it out just because I needed something, and this is a particularly pretty one, and so let's work through this. First off, the first term is x to the 4th, right? Now, the second term will go plus, okay, this will be negative 1 minus 2 minus 3 minus 4 times x cubed. Okay, this term, okay, negative 1 times negative 2 is 2, negative 1 times 3, negative 3 is 3, negative 1 times negative 4 is 4, plus, okay, negative 2 times negative 3 is 6, negative 2 times negative 4 is 8, and then finally negative 3 times negative 4 is 12. That's times x squared. All right. Negative 1 times negative 2 times negative 3 is negative 6. Negative 1 times negative 2 times negative 4 is negative 8. Okay. Negative 1 times negative 3 times negative 4 is negative 12. All right, and finally, negative 2 times negative 3 times negative 4 is negative 24. And the last one, we will have negative 1 times negative 2 times negative 3 times negative 4, which is 24. And I can write this out now as x to the 4th minus 10x cubed plus 35 x squared minus 50x plus 24. Okay. All right, now I've got this. How do I know that I've done it correctly? Because, you know, I had kind of a little cranial flatulence with this term. Maybe it's wrong. Well, what I know by looking at this, I know what this is evaluated on each of these. I can evaluate this then at evaluated at -1 and evaluated at -2 and evaluated at -3 in order to check and see if I do indeed get 0 at each of those. So let's see how I might do that. I would go do this by Horner's method. Okay, which I would have 1, -10, 35, -50, 24, and evaluate it at the number 1. So bring down 1. 1 times 1 is 1. -10 plus 1 is -9. -9 times 1 is -9. 35 plus -9 is 26. 26 times 1 is 26. Okay. -50 plus 26 is -24. -24 times 1 is -24. 24 plus -24 is 0. Okay. For the sake of time, I'm going to tell you that it works for each of these. I'm going to suggest that you, as an exercise, carry through this for 2, 3, and 4. It will be, you know, it'll make you a better person.